The next radio is a Magpie Autoscan 5000, UK made set, very high quality printed circuit board for the time. VMOS transmitter output, and one of the first sets, the very first one of these I ever got to see, had got a blown output, which was supposed to be indestructible. Now then, this has come with a bracket, which is not ideal because I'll lose it. It's come with the instruction book. I'm going to put these in the bag for now. I think we've got this on file, but I will just check. Comes with the circuit diagram. Yeah, it's a long time since I've seen one of these. I think I did one about 2014 last, so 10 years ago. Right. So it is the same as communicators in i440DX. So I think the best thing to do is to borrow one of the new leads we have in stock, which we manufacture. Oh, don't think these are cheap. I think that they're $7.99, but there we go. And you know what? It's the opposite polarity. No, it's a loose fit and it's the opposite polarity. I think we're going to have to open the setup first. Yeah. You know what? I can't remember which way round. I don't know whether it's the bottom you take off or the top you take off on these. All self-tappers. Right. Not a lover of the very thin wires, but you know, nice printed circuits. As I say, I can't see any popped capacitors. The positive has a choke on it, so we'll use this and have to put it the other way around. So it does fit, but it's the opposite polarity. We could specially make them for Magpie, of course. What a good idea, Mr. Tango. And there we have on 19. Well, it was a moment, it is, yes. Now it's come with the microphone, which I'm glad it has, because it's a weird one with it having the buttons added. Good, so they work. So we'll plug in extension speaker, mic gain, RF gain, squelch down. That's nice and lively. Power high, channel 9. Oh yeah, there's an anomaly. Channel 9 goes back to 19. Picture in picture on. Oh, meter bulb works. That's one thing done. Right. I had a friend bought one of these from a car boot sale. And he paid £12 for it. That's the one which I said had got a Duff output device, which is VMOS in these, if I remember right. So I sorted it out for him as a friend, you know, like parts cost. And about 5 years later, I said, whatever happened to that Magpie Autoscan that you had? And I fixed for it. I put it back in a car boot sale for 12 quid. Well, you could have offered it me. I mean, the sample wheel I've shown you before, which I bought to do a video on, was in the right sorry state, and all the scan generator stuff not working. So there was a lot of changing of logic ICs. But I got there in the end with it. Right, transmit. Are we on picture in picture? We are. Do these do 4 watts? It's doing 3.5, so that's a jolly good start. So channel 10, 1, 5, 4, 3, 2, 1. It is 3.5. Channel 40. It's 3.5. That's nice and balanced. Back to channel 20. Check the current consumption. It's 1.284. And low power. (330 milliwatts). Deviation, for what it's worth on this test set, wow, 1.2. I hope that's lying. There's no VCO method. Frequency 2779131. When you press transmit, let's go back to high power. Centre of the red zone, so it's correct. So on receive, let's put the frequency counter up, and you can see where I am. So 2779. We said this is the same 131 that it says it is, for fairness. So 100 microvolts, and it's a bit generous. Meter should be there, which is 17 microvolts. That's a very generous meter. Just check PA. Testing 1 2, testing 1 2, 1 2 1 2, testing 1 2, 1 2 1 2, 1 2 1 2, 1 2 1 2. Mic gain is a bit dirty. This is the kind of controls that you can get into to clean. Good, that works. sockets work, potentiometer, mic gain, dirty. Let's have a look at that circuit diagram. Is it one of those where transmit and receive separate? So VC1 is the 10.24, so that's our frequency adjust. VC3, VC2, VC1. So tell you what, we'll just put it on frequency. Good quality trimmers. We'll leave it there, just that little tiny bit lower. So if we look at the transmitter, see what adjustments we've got. T5, T6, T7, T8, T9, T10. Right, we'll start at T10. T9, that's the last one in the chain, surely. Am I misreading that? It's T5, isn't it? T5, T6, T7, T8, T9, yeah, it's down there, and our receive ones, not a lot. We've got a detector which is going to be T1, which is there, and then the two in the receiver I'm showing 3 T2, 3 and 4. That's 4. Yeah, got it. T2, T1. Does have a crystal filter. 10L1G. Right, start with the transmitter. Oh, you don't have an overall power, do you, on these? It's going to be a long video because I've got to find my way around it. See how high-low power works. It's fixed. Right. Tell you what, it soon drops off as it warms up. I think this needs... if I feel the temperature of the tab on the transistor, that's getting hot, and the case isn't, I think the heatsink compound has failed, or isn't far off having failed. I think we'll unmount that and put it back on. Yeah, it's getting too hot. So it starts off at, you know, like 3.6 watts and it drops to about 3.1 in a matter of 2 seconds flat. Which is alright for short overs. Do you copy, Roger? Are you nearly there, Roger? Is that it, Roger? 10-10. 10-10. I'd have cleaned that board better. Oh, it's got all these shims. Right, I'll take the power off. Well, I don't know about you, but I can't see any heat transfer compound on that mica. Absolutely nothing. And it's not one of those heat transfer pads you get these days. Either it wasn't policy to fit it, or it's gone. Okay, where's the cloth to wipe my paws on? The next snag is that there's a limited amount of pressure you can put on these nylon nuts and bolts. It's a metal nut, isn't it? It's a nylon bolt on it. And that's the amount I'm putting on it. Right, try again. Power back on, channel 20. And you can see we now have heatsink compound on there. Okay, so what colour tool? I wonder if it's the blue one. Yeah. Soon drops to 3 watts. At least the case gets hot now. Yep, 3.6 it is, no improvement. Oh well, tried our best. Should we do next? We could do deviation on the test set behind me. Wow, oh, it's 1.5, it is quiet. The deviation is going to be somewhere around there, isn't it? It's VR2. And VR2 is there. Wallow. Wallow. There we go. That'll improve its range, won't it? It's 1.8, 2.2 with a peak of 2.5. 3.6 watts so far on there. move away from the transmitter for now. The meter, well, I'm not done with the transmitter, so the meter was spot on anyway. Last time every time I've seen one of those, I've been disappointed with the receivers. That doesn't mean that users would be disappointed with the receivers, but there you go. I'm not sure whether the crystal filter was an option on these. We've got the ceramic filter, which we can see there. Yes, so it shows as a ceramic filter normally, and this one's got a crystal filter. And there's some component alterations around there, so I think it was a factory option at the time. Right, see where we are with that. All we've got to do is find the plug. Don't need an earth. So right now, let's see what we've got. Let's put the camera on. I'll tell you what, we'll put this blue trimming tool away while we've still got it. Go to camera 4. Right, 0.51. It's about like what the Uniden was yesterday. And then for 10 dB, 0.43. And then for not quite 1.4. Squelch on full. It's not far off ideal at 250 microvolts. Full and at minimum. Not 0.64. I'll see whether there's adjustment for that, but it's pretty well ideal as it is. We've got noise on the squelch control, so that's another one for the cleaner. I don't want to clean things willy-nilly because you can end up chasing the lubricant out. See, that feels alright. And I've yet to evaluate RF gain. Right, that's those done. So we'll start by putting the detector up and we'll have a look at 100 microvolts, some volume. Not the best waveform in the world, but there you go. That's already at the best you're going to get. I put these dodgy waveforms down to crystal filters, you know, I think they go lopsided. So I think the IF one is the L1 over here in the naughty corner. Let's go out there. Drop the attenuator so we've got... I'm not even showing you the right meter. Drop the attenuator so we've got about 4 dB, and we'll do the front end. That's interesting, that's a bit more out than I'd expect. Go back to that one. See what that reads. .42. .35. No, I'll say 0.36 and be less generous. We've definitely got 20 dB at 1. Now, squelch to full. Is there a preset for the squelch? So, squelch is there. So there isn't a preset for the squelch. So what you get is what you get, but it was pretty well where it should be at 250 microfarads. I like them to be 100 microfarads, but there isn't a hard and fast rule. So let's just see. In fact, I'll put the attenuator back on so you can see where I am. I definitely will find the right camera. At the moment we're at 150, 60, 70, 80, 90, 200. It's coming in at 200 now. So by getting the IF better, we've got an improvement on squelch activity. Let's just see where we are now at the other end, at the sensitive end. Turn it down. Threshold on the radio. Really nice solid aluminium knobs. Straight in. 0.3. Now, meter was squelch was a bit, wasn't it? Sorry, what am I on about? We need to be talk about the meter. So the meter on this so we've got an adjustment for the RF side. Have we got an adjustment? It says to B. Let's go over to B. No, I can't see any adjustment for that. I wonder if it adjusts with this, and then you get what you're given on transmit. But I'd rather it adjust with the S meter than with it for transmit. Let's see what happens with VR1. VR1's there. So we're going to put 100 microvolts on the signal generator. And of course we've got, well, I'll tell you what, we'll get the signal generator, so we've got S9. And S9 is now 11, 12, about 13 microvolts. It's far too generous. No, it doesn't affect it. Oh well, what a shame. They're the only two presets. Set this back on transmit. See that? Centre of the red zone as it should be. Right, time for a break. Okay, so we'll get this finished. A bit of rework on this side. Some of it could be to do with that crystal filter instead of the ceramic one, which was factory. There's some very fine wires doing some rework there. I think one of the options was this was fitted with booting up on channel 19 rather than channel 14. Anyway, there's a picture of the bottom. So there we are, that's what we're going to get from it, and I'll do a final power test when I put the bottom lid on. Testing 1 2, testing 1 2. Right, we'll have a look at the power output, and 3.6 on channel 20, 3.5 on channel 40, 3.5 on channel 1. So that's as balanced as we're going to get. From cold it's going to be greater than that. So it's exactly non-adjustable. That's fine. Switches are fine. Did I hear a bit of crackle with the RF gain? Let's just have a listen. Helps if I go back to channel 20 there. Let's squelch. Well, that seems smooth enough. Good. Right, we'll get the speaker lid put on. I've put the shims in. It takes a lot of putting these together. Just turn the power off. Case lids are heavier than you'd expect. It doesn't matter which way around it goes, but once again, let's see whether we can find which the earth is for no reason whatsoever. Not that one. It's that one. Check it works on its own speaker. And the fourth screw's on the floor. Right, we'll take it off the test gear. Let's put the squelch on. Unplug the aerial in instead, so take the power off to the test gear. There's a auto dimmer on the there's a LDR there. I'm covering the window. They call it a magic eye in the instruction book. See if the scan thing works. You can scan for a busy channel or a free channel. However you initiate it. Do I have to look in the instruction book? It says the powerful feature is available on no other transceiver we know in Britain today, which was true. Oh, you press one of the buttons, do you? Does it not do it automatically? Do you hold on to it? Yeah, you do. Yeah, you actually hold on to it. It doesn't scan, so it's found it's found interference. Go up next. Some SSB junk. Conversely, you could do the opposite. And it's not going to find anything. It's because that's looking for a free channel. They're all free. There we go. And then that's normal channel. One nano Roger. And we haven't got any of those. Well, he's off frequency, as usual. Right, we're doing on the air test for that. Oh, I never checked. We never checked low power, but there'll be no alteration, so I'll quite calmly not put that down at all. And the current consumption is actually 1.253. What did we do? Heatsink, compound, output transistor. Good, here we are. We're doing on the air test. Thanks for watching Magpie Autoscan 5000, about 1983.